the Fragmentation Mystery. Something strange is happening to 3I Atlas, and it might be tearing itself apart. When astronomers compared recent observations with earlier data, they noticed a subtle but undeniable change. The comet's brightness was flickering, not randomly, but in a way that hinted at cracks forming within its icy nucleus. At first it looked like normal outgassing, frozen gases escaping as the sun's heat reached the surface. But the pattern didn't match a simple jet of vapor. Instead, it looked fractured, like multiple pieces breaking away, each releasing dust and gas of its own. The European Space Agency's ExoMars orbiter recorded this faint variability during its Mars flyby, while earlier Hubble data showed a smoother, more stable glow. That difference set off a wave of quiet excitement or concern among mission scientists. Was 3I Atlas beginning to disintegrate, just like the interstellar visitor Borisov did before leaving our system? If that's true, the comet could vanish before it ever reaches its closest point to the Sun. But if it holds together, it might reveal new clues about how interstellar comets survive such extreme journeys. Either way, the clock is ticking, and every new image could be our last clear look at this fragile traveler before it breaks apart forever. Interstellar origin confirmed. It's official. 3I Atlas isn't from around here. When scientists traced its path through space, the math didn't just surprise them, it rewrote the comet's entire story. Its orbit wasn't an ellipse like every other comet bound to the Sun. Instead, it was hyperbolic, a perfect signature of something passing through our solar system from far beyond. That one curve of motion proved it. 3I Atlas came from another star. Data from both NASA and ESA confirmed the trajectory. The comet is racing through space at nearly 130,000 miles per hour, moving too fast to be caught by the Sun's gravity. It entered, swung around, and will soon disappear forever. A visitor just passing through. For astronomers, this wasn't just a neat discovery. It was a window into the unknown. Every grain of dust, every trace of gas trailing behind it carries the chemistry of a completely different solar system, one that might have formed billions of years before our own. So when you see the faint glow of 3I Atlas, you're not just looking at a comet. You're seeing a message from another corner of the galaxy, a cosmic traveler bringing secrets from a star we'll probably never find. And that changes everything. Unusual green glow. No one expected 3I Atlas to glow this way. When telescopes first picked up its eerie green hue, scientists around the world took notice. The color wasn't just pretty, it was a clue. Green light in comets usually means something specific. Diatomic carbon, a molecule that glows bright green when exposed to sunlight. But here's the twist. 3I Atlas isn't a typical comet from our solar system. That same green shimmer could point to a completely different chemical fingerprint, one forged in another star system. Observations from both Hubble and the ExoMars orbiter confirmed the color wasn't a camera trick. The glow surrounded the comet like an emerald fog, fading into the black of space. Some early viewers online jumped to wilder conclusions, calling it proof of artificial light or alien tech. But the real explanation is no less fascinating. That glow comes from sunlight breaking molecular bonds, a chemical reaction happening right now as 3I Atlas heats up near the Sun. It's chemistry at work on an interstellar scale, a process both familiar and foreign. And for scientists, that green light isn't just beautiful, it's evidence. Proof that even across galaxies, the laws of physics still speak the same language. Massive Coma cloud. The coma of 3I Atlas isn't just large, it's colossal. When ESA's ExoMars orbiter turned its cameras toward the interstellar comet, what it saw stunned researchers. Surrounding the tiny nucleus was a vast, ghostly cloud stretching thousands of kilometers into space, a halo so wide it dwarfed Mars itself from certain perspectives. This wasn't just sunlight bouncing off dust. It was the comet's icy core waking up, releasing gas and debris as it felt the Sun's growing heat. What made it even more remarkable was its scale. Based on ESA and NASA data, the coma could extend over 300,000 kilometers, roughly the distance from Earth to the Moon. That means most of what we're seeing isn't the comet's body at all, but the fog of vaporized material trailing behind it. Scientists call it a living atmosphere, one that expands, shifts, and flickers as the comet rotates. Within that mist lies the chemical fingerprint of another solar system. Carbon compounds, frozen gases, and alien dust now mixing with our sunlight. To the naked eye, it's just a faint blur. But to astronomers, this massive coma is a glowing laboratory, a drifting cloud of clues from a world born under another star. Hyperbolic orbit path. This orbit shouldn't exist, and at least not for anything born here. When astronomers first plotted 3I Atlas's trajectory, the numbers didn't bend into an ellipse like every other comet in our solar system. Instead, they formed a hyperbola, an open curve that never loops back. That shape told scientists one shocking truth. 3I Atlas isn't orbiting the Sun. It's escaping it. At nearly 130,000 miles per hour, the comet is moving too fast to ever be pulled into a return path. It entered from deep interstellar space, cut across our system like a cosmic arrow, and will soon vanish back into the dark, never to be seen again. What makes this so rare is that only two other objects, Oumuamua and Borisov, have ever shown the same hyperbolic path, and each time they've challenged our understanding of what kinds of travelers move between the stars. Every observation, from Earth and from Mars' orbit, confirms the same result. This is a visitor, not a resident. Its path is both a map and a mystery, proof that our solar system isn't isolated, but part of a much larger network of wandering worlds. Size, comparison, shock. It's smaller than we thought, but far more powerful than it looks. When astronomers measured 3I Atlas, the numbers didn't quite add up. Based on its brightness, the comet's solid core could be as small as 5 kilometers, yet its glowing halo stretches hundreds of thousands of kilometers into space. That's like a pebble surrounded by a cloud bigger than Earth itself. NASA's SphereX mission and ESA's ExoMars orbiter both picked up signs of an enormous CO2 gas plume, possibly extending over 348,000 kilometers. For something so small to produce that kind of outflow, it shocked researchers. It means this tiny nucleus is incredibly active, venting gas and dust at a rate we've rarely seen, even in much larger comets. Compared to Oumuamua and Borisov, 3I Atlas sits right in the middle, not the biggest, not the smallest, but definitely one of the brightest. And brightness in this case tells a story of energy, heat, and motion on a truly alien scale. So while its solid form could fit inside a single city, its presence fills half a planet's orbit, a reminder that even the smallest visitors from deep space can leave a massive cosmic footprint. Speed record breaker. Nothing in our solar system moves quite like this. Atlas is tearing through space at an incredible 130,000 miles per hour, fast enough to travel from Earth to the Moon in just under 2 hours. That speed alone places it among the fastest natural objects ever recorded by astronomers. But what makes it even more fascinating is why it's moving so fast. Unlike comets born in our solar system, 3I Atlas isn't bound by the Sun's gravity. It came from deep interstellar space, carrying the momentum of a completely different star system. By the time it crossed into our neighborhood, it was already moving too fast to ever be captured. A true cosmic drive-by. Every telescope that's tracked it, from Hubble to ExoMars, confirms the same thing. Its hyperbolic path and extreme velocity are signatures of an object just passing through. For scientists, it's like watching a messenger from another world blaze across our sky. Soon, 3I Atlas will slingshot around the Sun and vanish forever, a blur of light that reminds us how vast and how fast our universe really is. Amateur astronomers' contribution. It wasn't just space agencies that tracked 3I Atlas. Some of its earliest and most valuable observations came from ordinary people. Across the world, amateur astronomers pointed their backyard telescopes toward the faint smudge of light racing across the stars. Many of them were the first to notice subtle changes in brightness, the early signs of the comet's fragmentation and outgassing that professional teams later confirmed. These aren't scientists with billion-dollar budgets, just dedicated observers spending cold nights under open skies, collecting data frame by frame. Yet their findings helped refine 3I Atlas's trajectory, brightness curve, and rate of activity. Every logbook entry, every long exposure photo became part of the global effort to understand this interstellar visitor. The collaboration between amateurs and space agencies like ESA and NASA turned into a rare, worldwide experiment, a moment when human curiosity united across continents and disciplines. And it's a reminder of something bigger. That the frontier of discovery isn't only found in high-tech labs or orbiting spacecraft. Sometimes it's in a backyard telescope, where passion, patience, and a clear sky are all you need to help decode the mysteries of the universe.